Welcome, you guys. We are moving into Matter 1. So our first learning target, we are going to start out by learning about mixtures. So mixtures make up all sorts of different things. And when we talk about mixtures, mixtures make up kind of a big, broad category underneath matter. And so if you take a look at your note sheet, all matter can be classified into three categories. So if we put matter at the beginning, remember matter makes up anything. Everything is made of matter. Matter also makes up mixtures, which we're going to learn about in today's lecture. Later on in the unit, we'll learn about elements, and then finally, we'll learn about compounds. So make sure you write these three in your boxes. So what is a mixture? Well, a mixture is a bunch of different things. A mixture, first of all, is a combination of two or more substances that can be separated physically. So it's not just one substance, it's 2, 3, 4, 5, 6, whatever's in it, but they have to be able to be separated physically. And when we say separated physically, we mean that you can maybe filter it through a coffee filter, maybe you can put it in a colander like you would drain your pasta, or maybe it's something like your pasta and your spaghetti sauce. You can pick out each individual noodle. So that would be a mixture that can be physically separated. Mixtures also have no specific proportions. They just mix. So we don't have 25% of this or 75% of that. They just mix together. Solids, liquids, and gases can also combine to make mixtures. So we learned about air last unit, and air is a mixture of nitrogen, oxygen, carbon dioxide, water. So there's lots of different things that come together in our mixture of air. And finally, when we create a mixture, no new substance is formed. Each part of the mixture keeps its own properties. So again, going back to our spaghetti and noodles, yes, we have a mixture of spaghetti with spaghetti sauce, but our noodles have a different property than our spaghetti sauce. Just like our air is our mixture of oxygen and nitrogen and carbon dioxide and water, each one of those elements have a different property of their own. So we can classify mixtures into two different types. The first type on the left-hand side of your notes are homogeneous. The word homo means the same. And the second type is heterogeneous. The word hetero means different. So let's start with homogeneous mixtures. If we said homo means same, then a homogeneous mixture is evenly distributed, which means if I take a look at that, let's say a can of pop. Everything is distributed evenly throughout it. When you take a sip of that can of pop, you don't get a sip of sugar and then a sip of carbonation and then a sip of water. The materials are evenly distributed throughout. And so it almost looks like there's only one substance there and just one material. So we would say that that has one phase to it. So make sure you go ahead and write down an example of a homogeneous mixture other than the pop example I just gave. Heterogeneous mixtures are not evenly distributed, so they have all different parts throughout it. So typically we can see more than one type of material in the mixture, so it would have more than one phase to it. So my spaghetti could be an example of it because it wasn't distributed. Maybe you'll have meat sauce in one, maybe chunks of tomatoes, maybe some noodles are fully covered, some aren't. There's a couple different things mixed in it, so it's more than one phase. So be sure to come up with another example besides my spaghetti one. So we keep on talking about this phase. So what is a phase? A phase would be each material that can you see in a mixture. So in my pop example, I could only see your pop, for example, a Coke. I just see Coke. So that would be one phase. So each time you see a different material, that would be a phase. So there would be your example of your pop. Now, my spaghetti example has more than one, and so that would be considered more than one phase, or two. Here's an example of oil and water. So oil would be one phase and water would be one phase. So that's two phases, and so we would say that that's heterogeneous. And then finally, in this example of trail mix, you can see there's raisins, there's cashews, almonds, M&Ms, and maybe some peanuts mixed in there. So that's 4 different phases, which would make that a heterogeneous mixture. So we're going to get a little bit of a practice. And so we have a lab, a little mixtures lab. So you're going to have to go find the teacher. And I will give you a bunch of different examples of either homogeneous or heterogeneous mixtures. And so for each one of those, you're going to write down your observations. So for the wood block, you'll tell me what you see. You'll say if it's 1, 2, 3, 4, 5 phases, and then you'll identify whether it's a homogeneous or heterogeneous mixture. After that, be sure to show the teacher, and then finally you can complete your mixtures foldable. And so you're going to take that sheet of paper, fold it on the solid line so that these pictures fold in on you. You're going to color those same particles the same color. Cut on the dotted lines to create 8 little flaps, and then underneath each flap you're going to identify whether it is a mixture or not a mixture. If you need help, please see the teacher so you can get your questions answered. Thanks, guys.